A very good morning to each one of you present here. We, the Group 7 members, Arun, Shivakumar, Vaishak, and Ramesh, are here to present the final review on our project Automated Floor Cleaner. Before starting the presentation, I would like to thank our guide Srija Miss for the constant support and guidance she had provided throughout this project. Also, we would like to thank Sushma Miss, Head of the Department, Electronics and Communication Engineering, for valuable support. As we all know, in this fast moving world, each and everyone is busy with their day to day work and do not have enough time for cleaning. Cleaning in either households or industries is usually carried out by humans and thus it is time consuming. The whole idea of reducing manpower and time consumption help us to design and implement our project Automated Floor Cleaner. The main part of the system is Atmega 2560 microcontroller. The system also includes ultrasonic sensors, proximity sensors, motor and motor driver circuits, and a lithium polymer battery. At first, we were thought of using Arduino Uno as microcontroller, but the number of pins in Uno was not sufficient to incorporate all the components of the system. This drawback was later overcome by using Arduino Mecha microcontroller, which consists of almost 54 digital input-output pins. The whole automated floor cleaner system consists of two units, suction unit and mopping unit. We first started off to make the suction unit. The outcome of the unit is to concentrate the dust particles in front of the device to the inlet of vacuum cleaner. To start with the vacuum, we first use aluminium sheet for making propellers. The bending of the fin of the propeller was done using bare hands and this caused an unevenness in the shape of the propeller. This ultimately led to the reduction of suction power. The motor used was 24 volt 775 DC motor. The shaft of the motor was too large, which led to the increase in current dissipation and size of suction unit. These all drawbacks were ultimately overcome by using brushless DC motor and 3D printed propellers. The material used for 3D printing was polylactic acid, commonly known as PLA. The advantages of using PLA were is inexpensive, renewable, and most importantly, it's biodegradable. So, by using BLDC motor, we were able to obtain the required suction power and it also reduced the size of suction unit. To concentrate dirt to the inlet of suction unit, two side brushes are provided which rotates in opposite direction. The movement of the side brush is controlled by bow motor which produces high torque at a low current. Initially, the vacuum inlet of conventional vacuum cleaner was used for the system. By using it, we didn't get enough suction power so that we redefined the vacuum inlet with a 3D printed model. Thus, the expected suction power and efficiency were achieved. For the storage of dust particle, after passing through the vacuum chamber, it passes through a hole and gets deposited on a dirt bag. A rail placed at the bottom of the cleaner helps for easy detachment of dirt bag. Next section of the system is a mopping unit. The mopping section consists of a plastic box for storing water and a solenoidal valve for assisting the mopping purpose, which is controlled by a relay. One end of the solenoidal valve is connected to a water storage unit and the other end is connected to a sponge that performs the mopping operation. When the cleaner is turned on, the solenoidal valve, which is in the normally closed position, is switched to normally open for 30 seconds and then it simultaneously turns on after every 10 seconds. A specially 3D printed case is made to fix the three ultrasonic sensors and this case is mounted onto the MG995 servo motor. Here, instead of using one ultrasonic sensor for 360-degree rotation, three ultrasonic sensors are placed in such a way that each one produces a rotation of 120 degree in a single cycle. Here, we are using 6 proximity sensors which is arranged in accordance with the ultrasonic sensors at positions front right, front middle, front left and in the similar manner at the rear side. Ultrasonic sensor provides the aerial view whereas the proximity sensors provides the depth information. For every 120 degree of rotation, each ultrasonic sensor provides 12 values. So, a total of 36 values is obtained in a single cycle. In the case of proximity sensor, at a particular instant, 6 values are obtained. An array is used to store these values and a logical AND operation is performed for the mapping purpose. By using the above result, the cleaner itself can identify its position and the obstacles all around it. The main objective of our project was to develop a fully automated floor cleaner which is suitable for every environment. But we were unable to process the information from the sensor unit properly. Thus, the project was completed in a controlled environment. When we consider this as a product, the total expenditure is very much less compared to other floor cleaners in the market. This is because the only expensive part in our project is the LiPo battery, which thus makes our product cost effective.